Hello and welcome to this course Machinery Fault Diagnosis and Signal Processing. Today's topic is introduction to faults in rotating machines. There may be a number of faults in the machines, but 90% of the faults they can be categorized into four categories, that is misalignments, imbalance, looseness, or bearing or gear wear. So misalignments basically deals with shafts, imbalance deals with the rotors or gears, looseness is something related to bearings or gears or foundation, and bearing and gear wear belongs to bearings and gear respectively. So in 90% of the cases the faults belong to the rotating parts, and that is why uh, arresting the rotating faults at an early stage becomes very important. In today's lecture we are going to see what are the different types of faults in the rotating machines which needs to be arrested at an early stage, so that the life of a component or life of a machine, efficiency of a machine can remain high for the design period of time. So what are the common faults in the rotating machine? Now consider this is an arrangement. This is a prime mover. Now prime mover can be an electrical motor or it can be an IC engine. This electrical motor is coupled by using a coupling, and here you can see that uh, a pump or a gearbox or uh, whatever the machine that you wants to run by using this prime mover is coupled here. Okay. Now this is the shaft. On this shaft gears are arranged. This particular picture is about the gearbox, the driving shaft and the driven shaft, and the power is transmitted through gear. So this is a gear and this is a pinion, and the driven shaft is connected to a pulley, and from this pulley the power is further transmitted to the other members, other machines, other parts. Okay. Now what kind of faults may be there in these arrangements? Now first and foremost, these shafts are connected, two different shafts are coupled together, so there may be shaft misalignment. uh, Misalignments may be parallel misalignments or annual misalignments. There may be cracks in the shaft. Similarly, the foundation holes may be used. This is for soft foot. So foundation holes of the rotor, foundation holes of the gearbox may be used, and this fault is called soft foot. Then these pulleys or gears may be imbalanced. The mass of the pulley has to be concentrated at the center of gravity, and the center of gravity has to be matched with the axis of rotation, but because of the uneven distribution of the mass about the center of axis, then the rotor tends to imbalance, and because of the imbalance a centrifugal force is acting in outward direction, and which creates the vibrations. So gear imbalance or pulley imbalance is a very common fault in the rotor system. Then bearing faults are there. uh, this is a non-drive bearing and this is drive end bearing, and there may be different bearing faults, such as bearing consists of different components like outer race, inner race, rolling element, cage element, uh, and any defect in these elements leads to bearing failure. So there are bearing faults. uh, then a gear may be cracked, gear tooth may be cracked at the base, gear tooth may be broken, spalling or some rubbing may be there,
at the shank or at the flank of the gear, that is called spalling. These kind of faults may be there in any machine. Okay. So these are the various types of faults which are indicated in any common rotating machine. Faults in the rotating machines are need to be arrested because at high RPM a small fault is aggravated to large extent within short period of time, and that is why these faults sometimes become very fatal. Now these are the faults: unbalance, misalignment. Misalignment are categorized into parallel and angular misalignments. So misalignments are basically related to shafts. Unbalance is related to rotor. Cracks are related to gears, bearings, shafts. Looseness is related to bearings or gears or foundation. Bearing faults related to bearings which include inner race damage, outer race damage, rolling element, cage, etc. Gear faults are categorized as crack, spalling, or broken tooth. Rubs related to erosion or corrosion of the surface, and when the when there is a relative motion between the eroded part, the rubs occurs. So these are some of the common faults in the rotating machine. Now there are, apart from these, there are some related faults in the rotating machine as well. And what are those? First is defects in machine casing. Yeah, casing may be cracked, like for example the gearbox casing is there. In that casing the entire arrangement of gears and pinions are arranged, and the stage wise reduction, speed reduction is there in the gearbox. So there may be a crack in the casing, there may be a leaks in the seals or gaskets. Soft foot, as I said, the foundation bolts may be loosened. So if proper shims are not provided at the foundations, then the foundation bolts, there may be a play in the foundation and foundation bolts, and because of that foundation may vibrate. Then there are prime mover faults. Prime movers are categorized into two categories, that is electrical motors and IC engine faults. Electrical motor faults includes bearing faults, stator winding fault, rotor winding faults, eccentricity of the rotor, and IC engine faults includes the ignition delays or the tappet valve faults, etc., etc. Then why machine fault occurs? What is the exact reason for machine faults? So these are some of the reasons due to which the machine fault occurs. First is wrong design. Okay, so designer may not be considered all the factors at the design stage, and designer may overlook certain conditions which otherwise machine faces during its operation, and because of that the machine fault occurs. The second reason is incorrect machine installation. So if the machine is not installed properly, there may not be a proper alignment between the shafts, alignment between the pulleys, then the foundation is not properly installed, proper shims are not provided at the foundation. So incorrect machine foundations may be the reason of machine faults. Improper maintenance, yes, proper maintenance schedule is not followed, proper lubrication is not provided to the components, and because of that, because of the less lubricant, a lot of friction occurs, and that friction, because of that friction, heat is generated, and the lubricant the lubricant get burn out, and it creates a carbon hard carbon particles, and when these hard carbon particles are rubbed between the two surfaces, then it erode the surface, corrode the surface, and
because of that, the entire component fails. So improper maintenance schedule may be the cause of the machine fault. Then electrical voltage fluctuation is also very important. Because of the electrical voltage fluctuation, so unnecessary shocks are experienced by the machine, and these shocks may lead to machine component damage. Then wrong operating conditions. Sometimes machine is provided with the load which is more than the design load, and machine is not capable of handling such high loads, and because of that machine fails. Then untrained operators are not trained. Uh, the standard operating procedure of the machine is not followed, and because of that also machine fails. So these are some of the
reasons why machine fault occurs. Then what are the effects of these faults? Because of machine faults, the machine breakdown occurs, the unplanned breakdown uh, may leads to long breakdowns, productivity loss, huge manpower hours are required, okay, high maintenance cost, low productivity. So these are some of the effects of these faults. Then how to reduce these faults, how to reduce these effects? The first is proper maintenance. Yes, proper maintenance schedule has to be there. All the machines are to be categorized into high precision, medium precision, and low precision machines, and accordingly maintenance schedule has to be followed, has to be maintained. High precision machine has to be maintained at a frequent intervals, and low precision machines maybe have high frequency. So like that, the proper maintenance chart has to be prepared. Some preventive maintenance and some predictive maintenance strategies are to be implemented so that the life of the component or life of machine can be prolonged. Then proper condition monitoring of machines. As I said, the precision machine has to be monitored continuously. You may use vibration analysis or acoustic analysis or thermography or motor current signature analysis, that is MCSA. So you can use the modern condition monitoring techniques for monitoring the working of some precision machines, and by using proper maintenance chart and proper condition monitoring techniques, you can actually reduce the effect of the machine faults. So this is it from the introduction to machine faults. From the next lecture we will see each and every machine fault in very detail. So thank you very much.